关系重来。Hi, today we'll introduce the technology of 5G and discuss its core technologies, challenges, and future direction. Next page. And this is our content. First, I will introduce what is 5G. Next page. So what is 5G? 5G is the fifth generation of wireless communication designed to support ultra-fast internet speed, low latency, and massive connectivity for devices such as IoT and smart cities. For instance, with 5G, you can download a full-length movie in seconds, enable real-time gaming, and powerful applications like autonomous vehicle and smart cities. And why is 5G needed? Previous generation like 4G can't handle the growing number of devices. The demand for faster data speed, particularly from video streaming, and the need for real-time communication. Next page. And 5G aims to increase capacity, allow more devices to connect at the same time, lower latency, enable real-time communication, important for things like autonomous cars or remote surgery, and boost speed, provide much faster data rate, up to 10 gigahertz per second or more. Energy efficiency, extend battery life for IoT devices. Reliability, ensure connection don't drop, even in a crowded area. Next page. And to achieve this advancement, 5G relies on these key technologies: millimeter waves, massive multiple input, multiple output, beamforming, smart city, and network densification. And I'll break each of these down next. Next page. Most of our devices today use frequency under 6 gigahertz, but as more devices connect, this spectrum is getting crowded. 5G solves this by using millimeter wave, 30 gigahertz to 300 gigahertz, which provides significantly higher bandwidth and capacity for faster and more reliable communication. This frequency offers immense bandwidth, but have some limitation, like they don't travel well through building or rain. Signal can get absorbed by plant and obstacle. To overcome these challenges, 5G use technologies like small cell for improved coverage and beamforming for precision delivery. Next page. Massive multiple input, multiple output, use hundreds of antennas at base station. This increased network capacity by 22 times or more by sending multiple data streams to users simultaneously. However, it broadcasts information in every direction at once, and overflows cross-crossing signal could cause serious interference. And massive MIMO can solve this by combining with beamforming, which can direct signal more efficiently. Next page. And this is beamforming. Think of beamforming like traffic signal for wireless communication. Instead of broadcast signal everywhere, it directs a focused stream of data to specified users, preventing interference. This is particularly important for millimeter waves, which have limited range. It's also critical to vehicle-to-everything communication, where precision are essential there. Next page. And because higher frequency millimeter waves had harder time traveling through obstacles like the left image. So in order to address this limitation, 5G deploys small cell, low power base station that cover short distance. These are densely placed in urban area to ensure seamless coverage and high capacity. This base station will be much closer together than traditional tower to transmit signal around obstacle, and this will be especially useful in city. As a user moves behind an obstacle, his smartphone will automatically switch to a new base station and allowing him to keep his connection.
Well, let's begin with the standards development. And there are some key organizations in here. First, we can see that 3GPP plays a central role, which defines the core network and RAN standards. Also, we can see that ECE, which focus on standardizing the multi-access edge computing. At last, ITU established the global goals for 5G under the IMT 2020 framework. And we can see there's a timeline here. In 2015, the 5G requirements definition comes. And in 2018 marked the release of 3GPP release 15. Well, it also introduced some critical features like IMBB and URLLC. And in 2020, the initial commercial deployments comes. Well, I'm gonna to move on trials and real-world applications. First, China IMT 2020. Well, it validates the efficiency of massive MIMO and waves. Docomo showcased how IMBB performs in dense urban settings. V2X trials demonstrated how low latency communication supports in the autonomous vehicles. And we can see on the right image, well, the diagram illustrates how V2X enables the communication between vehicle infrastructure and the satellites, and also in ensuring the reliable connectivity. Also, we can see some real-world applications. Well, in the healthcare, the remote surgeries are not possible for ultra-low latency. And in transportation, the autonomous vehicles use real-world communication for safer navigation. And in entertainment, VR and AR streaming comes. Well, I'm going to talk about technical challenges with this. Well, despite there's a lot of advancement, 5G also faced some significant challenges. First, the spectrum allocation. Well, it involves balancing the licensed and unlicensed spectrum. And in energy efficiency is a concern due to the high power demands of the dense small cell networks. Security remains critical with risk like rock base station and data privacy breaches. Now we can look at the graph on the right. Well, it shows how energy efficiency improves as the small cells are deployed, but this comes with the increased power consumption. And now this is a case study about cloud native microservice for MEC. Well, it reduced the slice migration delays through partial slice mobility. So we can see in the right image, which is about microservice architecture. And on the left is about monolithic architecture. So it is only one structure with this. Well, the next is the deployment strategy. The small cells can enhance the coverage in urban areas by complementing microcells. And the next is centralized RA, and it optimizes the resource allocation and reducing cost. At last, we are going to talk about edge computing integration. Well, it brings computation more closer to users, and it reduces the latency and enable real-time applications. So we can see on the right, the microcells include a lot of small cells with this. And now we're going to talk about the global deployment. So like countries like South Korea, the United States, and China are leading in 5G deployment. However, some developing countries, they have faced some challenges such as limited infrastructure and high deployment cost. At last, we're going to talk about future of 5G. Well, it has some trends with this, such as IoT and AI integration. It can power the smart cities with automated system and intelligent networks. Also, in the 6G roadmap. It explores like terahertz communication and improved spectral efficiency. Well, we can see the radar chart on the right, which compares the 5G and 6G so that it improves the efficiency and reliability and reduce the latency with this. Now we're going to conclude our slides. First, we talk about like 5G redefines the communication with some ultra fast speeds and also low latency. And like we talk about some technologies like millimeter waves and beamforming, which enables the efficient high performance network. And also some massive MIMO and beamforming, which are the key for handling high density environments. And also we talk about some small cells to ensure the seamless coverage for the urban areas. And we also talk about the standard development, which like 3GPP standards, it provides the foundation for 5G technologies like EMBB and URLLC in 2018, and some real-world trials which emphasize the transformative applications. And at last, we talk about some technical challenges like mobility and energy efficiency, which are actively addressed. And also 5G sets the foundation for 6G and beyond. So the 5G is not just a network, it's a platform that drives the next wave of technical innovation. Well, our presentation is finished. So thank you for listening.